Now, I think I should be very accomplished, feel very accomplished to suggest you know, the addressable cell block of decimals and operators as individual input points for new computer architecture, and to suggest how to go about doing the addition and subtraction and multiplication and division, because qubits and bits, they use binary, brute force. The qubits is faster, but it's brute force anyway. It's brute force, but they don't know it because it's so fast, right? Because like 2 in binary, right? Is I have to write it down. 2 decimal in binary. 00 is 1, 01 is 1. 00 is 0, 01 is 1. 10 is 2. 10 in binary is equivalent to 2 in decimal. 10, like we write 10, if those are binary numbers, it is just 2 in decimal, because binary numbers just use 0 and 1s. Now 1 in binary will be 3 in decimal. 00 is 0 in decimal, 01 is 1 in decimal, 10 is 2 in decimal, 11 is 3 in decimal. From 0 to 3 is 4 spaces, right? 4 movements on the number line. So 2 binary numbers have 4 possible combinations, right? So now I have 2 rows, 2 along the rows, up and down. The column is up and down, but what row I'm selecting in that column is by 2 binary numbers, and the rows across, but which column am I selecting? 2 binary numbers. Each of those, now I have 4 and 4, 16, right? Because 2 and 2 has 4 combinations. So I have a square matrix. Thank you, right? So now in those 16 cells of this block, this one block with 16 cells, I will have 0 through 9. I will have multiplication, subtraction, division, maybe square root, since the vacuum tube computer had square root. There is space for operators. Square root, no, just do arithmetic. Multiply, divide, add, subtract, positive or negative. The rest can be done in some other engine. So now one block has 16 positions. So that's like 16 bits if you select one at a time. Bit 00, the first box you can use in one thing, and the last box you can use in another thing. If all were bits, but they're not, only 10 are bits. Or numerals actually, because bits mean 0 or 1. you're going to program, I want to add 4 and 6 and 8. The programmer is going to say point to the address, um, location 4, location 6, location 8 I said, and you're going to say add. Then the instruction machine will carry out that instruction. Now if you have an equation that can have several possible values for that variable, say 9 possible values, you can put all the values right away and do 9 different calculations on that equation right away. You look at 9 possibilities. Now these possibilities can be determined from what you know. You investigate different possibilities at the same time. It does the same thing that Qubit does, except that you're doing perfect. You know what you're doing. And you don't have to kind of waste more money trying to build it anew. You have everything it takes to build it this way already.